The modern periodic table is based on Mendeleev's arrangement, but instead of being arranged by atomic mass, as Mendeleev's was, it is arranged by elements' atomic number. These are different because the atomic mass is the total mass of the atom determined by its number of protons and neutrons, whereas the atomic number is the number of protons in the atom. Arranging the elements in order of their atomic number solves some of the problems associated with Mendeleev's table. For example, in Mendeleev's table, iodine, which has a mass of 127, should be put before tellurium, which has a mass of 128. Why? Because iodine has a smaller mass than tellurium. But Mendeleev noticed that iodine has similar properties to fluorine, chlorine, and bromine, so he broke his own rule and put iodine within this column. In the modern periodic table, where the elements are ordered by their atomic number, tellurium, which has an atomic number of 52, would be put before iodine, which has an atomic number of 53, so they fit into their correct positions without breaking any rules. In the modern periodic table, there are currently around 115 elements, and although new elements aren't really being discovered anymore, new ones are being made by scientists. These new elements are highly radioactive. Radioactive elements have an incredible short existence because they decay very rapidly. But if we know where they could be on the periodic table, we can make really good predictions about the properties that they would exhibit. In the most basic form, the periodic table can be split into metals and non-metals, with the metals dominating most of the left-hand side of the table and the non-metals on the right. There are subcategories within these which we will learn about throughout the course.